Here is going to be a panel discussion by Kim. He's going to be asking me some questions that I suggest. So
All right, good. Still morning. Good morning, everyone. We are about to kick off the next session in here. I have, frankly, already forgotten the name of the session. It is a panel discussing the teaching of coding in a variety of ways. This is an unusual thing for us to do, certainly from the PyCon ZA front. We've tried to organize panels before and only ever had a few, but they go very well when we do. I'm just going to introduce the guests. I am but the person doing the moderating. I don't actually know anything about this topic. They pick me because I'm happy to just waffle. I will shortly stop waffling and introduce, and we'll get actual insights from people who know what they're doing rather than myself. So starting around from this is my left hand, starting from my left, Dr. Stephen Levitt, who is a professor at Wits, you said, Dr. Stephen, thank you. Yeah. Angelique Trussler, who we met yesterday, is the Thank you. Associate Director of Community. I was going with Director, but it wasn't right. Associate Director of Community at Software Carpentry. Dr. David Mertz, who some of you would have had a fascinating talk from yesterday, with a union in the US, and apologies, I have forgotten its name already. I had it in my head. Yeah.
So I work for a union called Service Employees International Union, SEIU. But okay. In terms of my introduction, probably most relevant is some years ago, I worked for Anaconda Inc. that many of you are familiar with, and I created the training program for them that brought numeric and scientific Python to scientists, basically, or other kind of professionals.
Very cool. And finally, Sheena O'Connor. You would have heard Sheena many times. Sheena is our conference chair, but most importantly for this topic, Sheena is an educator with much experience at Umuzi and now her own gig, particularly interested in the teaching of teachers, which I'm going to take a seat just so I'm not kind of blocking everybody's view. And I'm actually going to kick off with a question about the teaching of teachers. Sheena has suggested a first interesting topic to talk about, and it struck my fancy as well. Sheena, your question was basically, I say basically, there's nothing basic about it, but a reflection on the importance of teaching the teachers who teach people code. I'm actually not going to bother speaking anymore. You can take it from there and we'll drive. Yeah.
Awesome. So we've all had good teachers and we've all had bad teachers. A lot of the time, the folks who teach code are people who either just like know some technical stuff, but haven't necessarily been taught to teach, or you get teachers who are transitioning into teaching code, but they've never actually worked as developers. So there's often a skill gap on one side or the other. In February, I was at PyCon Namibia, where we have a teaching day. So we were hanging out at a bunch of schools, teaching kids to code with Python and microbits, and it was really cool. And a bunch of teachers showed up, they're computer studies teachers, and they were all like cool and hungry to learn and eager to make a difference, and that was great. But then after interacting with them, I was like, damn, these people need support. They were passionate educators. They had so much time for the kids, but they didn't have the software development skills to do a great job. And so they were happy that we were there, but we were only there for a couple of days. So I got an idea out of that about setting up a mentorship program to pair techies with teachers, because like, for those folks in Namibia, like even a junior developer would be able to make like a massive, massive difference in their lives. Like even a junior developer would be able to like uplift a teacher, which would uplift like a lot of people. So that's something I care about quite a lot. And so I launched a community last year called the Guild of Educators, and we're putting together a mentorship program for people who teach code. Yeah, and it's pretty like low. It's not a very demanding thing for the mentor in this situation. It's a 12-week program. You have to meet up like once every 2 weeks, and all of the like organizing workload falls on the mentee. So they'll be so you're not going to have to chase anyone around. So if you're keen to just like make a difference in many students' lives, help a teacher out. I think that would be a great thing to do. Yeah.
Thank you, Sheena. And then I'm going to throw to any of the rest of our panelists who might have something insight to offer there. Oh, we can share this microphone as well, but yeah. Okay.
No, we'll share it among ourselves. I'm just kidding. Hello, everyone. I'm Angelique. Maybe I want to kind of build on what you have been talking, just share a personal story. So while I was doing my master's, I decided I wanted to do quantitative educational psychology. That's literally, I had this dream always, and those of you in the room, I'm not sure if any of you, in the humanities and social sciences, you do not get programming and statistical courses added. So when you get to your postgrad level, you are not well equipped to do quantitative research. It's like a cold word. You're just like, nope, I'm not going to do that. Stats is scary and I'm going to run away. And with open science, we encourage individuals to make use of open source software because it's free, and there's this huge community that supports each other. And this is where my journey with open science and open source has started. And now, sitting here many years later, I'm not going to give my age away, I want to say that becoming a teacher in coding, and some shameless self-promotion through the carpentries and the instructor training, I feel like I have the set of skills in my hand now that I can talk to anyone about anything, because I came from an ed psych background, and now suddenly I'm sitting here with you at a PyCon Africa conference talking about how do we teach coding. What we need to remember is globally, we teach differently and we learn differently in different sectors. And I think I'm in a very fortunate position to see this. When we teach a carpentries workshop in South Africa, it does look different. The pedagogy I want to say teach at the carpentries can be applied to different things, because we know pair coding in Africa works so well because this is how we do things on the continent, right? We sit together, we help together, where maybe in Europe and the US sitting in a chalk and talk type of situation might be better. So we need to think about diversity, inclusion and access when it comes to the various parts, but not just as ticking a box. I do feel it needs to be applied to the context we are currently in, and we must make it unique. It must be a valuable experience for the learners in the classroom.
Thank you. Anybody else?
Definitely. I mean, I admired for a long time the work of the carpentries, and it is absolutely fantastic stuff. I somewhat emulated it when I was able to create training programs. But to play a little bit off of what Sheena was saying, one of the things that I think can be extremely valuable, in much the way that I think that pair programming can be extremely valuable, is to be able to pair up teachers, some who are, maybe less technically skilled but more education experience, or vice versa, but also people who are simply more experienced in all of it, with those who are less in either the technical or the pedagogical aspects. And it's co-teaching. It's this particular course for this day or this week or something like that. But if the future educator is able to share that task with someone with more experience, that's, I think, in many times the quickest and best way to learn those skills.
Thinking about your comment. Hi, it's Stephen. In terms of teaching, I think I found like the more experienced you are, the greater the distance you are from the student. Like, that distance increases, and it's hard to kind of remember what it was like when you were first starting out. So, I mean, I was helping out at the Django Girls workshop, and there's just so many concepts that goes through, like databases, version control, web development, and class design. That's kind of, if you're experienced, you just sort of accept that you forget the challenges that students have to deal with. But it's hard you have to intentionally kind of put yourselves in the shoes of the student, the learner.
There's another one.
I've been picking up a cough. So on what Steve was saying, I fully agree. Like, getting into the heads of the student is a big part of the game of teaching. I mean, you need to know the technical stuff. That's really important. But like, I spent about 5 years teaching people the basics of code. Like, that was a big part of my job. And then I taught teachers to teach people the basics of code. And like, when you're teaching, you do learn a lot about what you're teaching. It is a fantastic way to learn, so that is one thing. That is one benefit. And it's not just a nice thing that people say, it's actually something that has been well studied. It's called there's a name for it which I can't remember right now. Just trust me on this. But basically, like if you're prepared to teach somebody else, you have to revise the information in a certain way. They ask you all these weird left field questions. You're like, I didn't think of that. That helps you build better mental frameworks. So you get technically stronger, and that's cool. You get better at explaining yourself to people who are non-technical, which is also cool. Like that is freaking important for a career. But last but not, but you do get to a point where, like, maybe you feel like you're explaining the same thing over and over again. Like if you've got a whole lot of new people and you're like, you need to learn about for loops, you need to learn about for loops, you need to learn about for loops. It can feel repetitive, but you can go a level deeper. If you really, really want your students to succeed, if somebody is struggling, you get into their heads, you just dig around in their brain and you act like a scientist and you say like, I think you might be misunderstanding it like this. And then you ask questions to test where the gaps in their knowledge are so that you can get a good simulation of their brain. And it's a really stimulating process. Like it's actually super fun teaching basics of code because the basics are weird to most people. Like for us in this room, we're techies, we already know how to code, but cast your minds back to when it was weird. It's really fun to unweird it for people. So, and there's a skill involved in that as well. So yes, the skill of teaching is a thing that can be developed.
If I can maybe lead on to a follow-up question, from what we've just been saying, that muchly the greatly the importance of teaching teachers to teach, is there something to be said then for, because many of us work in a large organization, as do I, is there something to be said that making sure we're taking the time that we're teaching our senior engineers how to mentor your junior engineers? Is there something to, is there a skill there? I feel there is.
Yes.
Okay.
Yeah, I think it's not taught enough. It's just like you have the technical skills. Make this person have the technical skills, and there's something missing there. There is a craft to teaching. There is science behind it. It is something that we are still studying and figuring out how brains work better. So I do think it makes a lot of sense to teach senior technical people how to make more senior technical people, because that's where they come from. They don't come from schools. They come from experience and they come from peers. So that's a really good thing. I'm hogging the mic. Does anybody else? Yeah.
It's a little bit of a different direction. Of course, I want to hand it to somebody else as well. And clearly there's different kinds of groups that you'll be teaching in your life. I mean, if they're fairly homogenous, maybe school children at the same age are going to possibly have a similar kind of level of knowledge that they're coming in with. But if you're teaching maybe even those, but certainly if you're teaching adults, they're going to have a great diversity of experiences, level of knowledge. And there's this challenge in, not boring anybody, but not challenging anybody too much. And a lot of it's in the design of the teaching material, but also a lot of it's in the presentation style. Make some things difficult enough that you know that it's going to go over the heads of a lot of people, but at the same time, return to the thing that's very basic. And there's a kind of cadence one learns as a teacher of doing that so that everyone stays interested, even in the things they don't get yet, but you do the very basic things too, so that it gives everyone an opportunity to catch up at least to a basic level in whatever it is. I mean, I also have a humanities background, I'm a doctor, but a philosophy, not any of these sciencey stuff. And so for me, it feels much like the way one thinks about rhetoric and prosody and writing styles of combining sort of different voices and different tempos in writing. And when I think of teaching material, I think of it, like writing a novel in that sense, that there has to be this compelling narrative with these different characters within it. That's perhaps a field, but we'll let somebody else go otherwise.
Can I add quickly? I want to add something that we are not taught how to teach at universities. This is how it is. And then we are taught skills to put us into the job market, which is exactly what it's meant to be. But then we kind of grow and grow, and professional development is sometimes not a main focus. There's a book I want to recommend for those of you in the room here, How Learning Works, 7 research-based principles for smart teaching, right? I felt as a professional development tool, this was amazing for upskilling me as a teacher. So even though I can do stats, even though I was a teacher, even though I'm an instructor trainer, this is great because it makes you think on a higher order level, how to help other people's thinking on higher order level.
Yeah, maybe just while we're recommending books, a book that I'm currently reading, which also is very interesting. It's called In Search of Deeper Learning. It's written by a researcher and a teacher, looking at students in American high schools. And it's actually very hard, to find deeper learning happening in schools. But the book isn't to decry the American education system. It looks at examples of where deeper learning happens. And it can happen in project-based schools. It can happen in, which are like very student-centric, but it can also happen in schools where teachers drive the curriculum. And there are trade-offs that get made. But it's a very accessible book. It doesn't have a lot of teaching pedagogical terms, so it's definitely worth reading. I was just thinking about, when you said teaching makes you examine your own understanding of a subject, and I've really found that, and it can be quite tricky to communicate well. So I teach C++, and pointers are always a challenging thing for students. So it's good to just kind of draw that in a diagram, draw a pointer, and that's kind of fairly leads itself fairly straightforwardly to a diagram. But then you get references, which are aliases in C++ for an object. And where do you put that on the diagram? And it took me a while to see, okay, that's just, there's a conceptual level where a reference is the same object as a pointer, and you can never access its underlying. It must be stored somewhere in memory, but you can never access that. So you've got an implementation level, but you've got a conceptual level, and students will you only need to, you need to understand the conceptual level. Once you understand that, you can understand the code. So to come up with the right diagram at the right level can be challenging.
Does anybody have a further comment, or otherwise I'm going to lead us into a follow-on question from that? The follow-on question that occurred to me, and as you were saying, Dr. Stephen, about conceptual levels, something that I do think you see a lot of, and again, this is entirely layman, I don't teach people at all other than a little bit of kind of work type mentorship, and people leave knowing less than they came with, so maybe that's not helpful. From a educational perspective, is there value in making sure we're teaching concepts over teaching how to use specific tools? Yeah. Is there something to be said for, I actually don't care whether you learned how to use Python 3.14, Python 3.13, in fact, whether you learned Python or Java or anything, it's that you know how a for loop works. Is that kind of what we're after more so than this is how you use the tool? But then do you square that against employers presumably saying, I need you to write this thing? Okay. Yeah. You pick the write this thing, I guess. Yeah.
Yeah, maybe I can start to that. So I mean, there's some schools that lean entirely on obviously concepts are key, but they might teach scheme or something that's hardly ever used. Because you can illustrate the concept. But I think there's a real value in doing both, teach that concept and teach how it applies to a language that's, fairly widely in use today, so that you can see, exactly how it plays out. I think just teaching a concept on its own, it's very difficult to appreciate.
I do agree with that, and I do think that we must remember that if we do not have the fundamentals down and how to teach, doesn't matter what you teach, it's not going to really go where it needs to go. I'm not saying every single person at an organization should be a teacher. However, I do think that fundamentals need to be put down. I want to think about a hierarchy. How many of you have heard of Maslow's hierarchy of needs, right? So right at the top, we want to self-actualize, but a foundation needs to be solid. And if that foundation's not solid, it's going to go all crumbling down. And you can see the psychology I'm bringing in here, right? It's a difficult question because if your company is not set on professional development and then education on a higher order, it's going to be difficult. I'm not saying impossible, but I think someone somewhere needs to get the ball rolling. Yeah.
There's a really difficult move to get in any kind of learners. I mean, no matter how sophisticated, whether it's school children maybe learning how to write a very simple program in Scratch or something, or it's doctorates at research institutes, but to go from the concrete technique you type these particular keywords in that order and it makes a program do something, to understanding what's the concept, what's the idea that we're trying to express with this particular code. And that's definitely frustrating. I've found as a teacher that you walk through examples, you have people write some code, it accomplishes some small task, but really I'm much more interested in getting them to generalize that. It doesn't matter what this narrow task is, this exercise, but that they understand why they're doing that thing. And when you get to that level, it's very easily transferable to a different library, a different programming language, a different algorithm, something like that. But I can't say I have a solution. I can say that that's a challenge for me, and I'm sure for everyone else in the room who's taught people, but I'm very interested in how others approach that, both my co-panelists and audience members.
So more on teaching the fundamentals and teaching the conceptual levels versus actually just seeing technical work. It's something that's really, really, really hard for educators, is getting a good view of what the learners understand. Assessment of skills is hard, and it's gotten harder now with all the LLMs and whatnot. The thing is, when you're teaching a person basic code, you give them basic problems to solve, and some of those basic problems are solvable by the hit the code with a hammer technique, which is you write the code, it doesn't work, you change some stuff at random, it doesn't work, you change some stuff at random, it's oh, it worked now, complete, hand that in. With little toy projects, sometimes that works, and sometimes it can be hard to just see into a person's head just by looking at their code to see what they understand and what they don't understand. So that's one example, but there's all sorts of different ways that people's misunderstandings can be hidden within the code. I'll give you another example. Let's say there's somebody who doesn't 100% understand how return statements work. This happens a lot in Python land because of REPLs. A lot of beginner programmers think print and return are the same thing. Just weird versions of each other. They're yeah, that's kind of the same. It prints it out because they use a REPL. Now, if you get one of these people to write some code, then the code will be repetitive and weird because they don't know how to use functions properly. And so you can look at their code and you can be oh, you just, you don't know the dry principle. Let me tell you about dry. Oh, now I told you about dry and your code's still not dry. Maybe you are a potato. Or maybe, or maybe you're just not conscientious. And so it's easy to make value judgments on people when it's really that the problem is that they're misunderstanding something quite fundamental. Now, in education, professional educators struggle with this. Now, people go into companies and they work in companies and they get educated by their peers in those companies and more senior people in those companies that aren't trained educators, that have a main job that's not education. And so folks who are missing these fundamental lessons, they can easily hit a ceiling, a glass ceiling that nobody can see what is from. It's just this person looks like they're not conscientious. It looks like they're not understanding even dry. How hard is dry? Look, you pasted the code. Don't do that. So again, for anybody learning to code, fundamentals are golden. But for anybody teaching code, look for those glass ceilings. It's really, really important.
Yeah, thank you.
If I can just comment on what you started off with there when you said, you can see the code, but maybe the student doesn't actually know what it's doing or how they got there. And I think that's really talking about are the learning outcomes being achieved? And that is a real struggle to to do, yeah, especially if you just have the final product. So, I mean, I think, yeah, looking at the process, the way in which something is developed is, and trying to assess that, again, which is, maybe not that easy, but with tools like Git, if students are using version control, you can see how their code is developed over time. You can get some insight into how they're actually building something. And that can maybe just actually be more important than the final product, especially with like the use of LLMs now.
And actually, not so much an answer, but I'm not sure what you have prepared, but actually raise a new question for the room. An anxiety I have is that with LLMs becoming more and more prevalent, that write code, but also that write prose. People write memos and essays and other kinds of writing that aren't necessarily source code, but obviously they write source code as well. And it feels like so many people at so many levels now just, have the machine do it. And I feel that is leading to a degeneracy of skill, both in language skills, in programming skills, in math skills, and a whole variety where this machine can do a simulation of those skills, but it even makes it harder for humans, for learners, to get an understanding of those things that they should. This is maybe just my, Skynet fear or something, but do anybody else want to?
Oh, well, I'm just going to chip in from a personal note to say, I think anybody who's been around, if you're just starting in your career, you may not realize that those of us who've been doing this for a long time, and I've been writing software for 20 years, I made 20 years of mistakes is how I learned stuff. You don't just magically, and if the AI does it all for you, the problem is you're not making those mistakes, and those mistakes, as painful as they feel, is how you actually learn.
So David invited feedback from the room. As a fellow David, I'll pick up on that. So in my work from 7 to 17-year-olds as well as adults, the thing that's really interesting to me is this thing that I call the loop of joy. We want to have an idea, struggle, and see it working. And in the work of test-driven development, we see this idea of red-green refactor. I don't know why anybody didn't make it red, green, blue, because that's another color. But when we're getting to green, we need to commit all the sins imaginable, right? That's the advice that's given, because we want to move from getting it to work to getting it right. And those are two different ways we have in our brain. If we're trying to do both at the same time, it's hard. So the get out of jail for me with this LLM conversation is then making it work becomes easier. And so refactoring becomes more important. And what do we mean when we say refactoring? We mean how do we make the code more understandable? Oh, I didn't understand it at all because I didn't write it. So now I need to go and understand it. And then I need to make it able to be extended. So that's where we get into the refactor side. And we need to make sure we can stick to that, find the struggle again. But closing that loop of joy quickly is not a mistake. To see it working, but then to try to struggle with it somewhere. We need to find those struggles, but not manufacture arbitrary struggles. It's a challenge, but it's very interesting to watch youngsters going through it in a completely different way.
So I've been doing quite a lot of mentoring at work, and something I find myself doing over and over again is reminding the people that I work with, who are at various levels of experience, from very junior to very senior, that what we're doing is actually difficult. It's not just type in some code and it works. And there are a bunch of factors that are kind of pushing us towards seeing it as easier than it is. When we review pull requests, we're not reviewing the 2 days someone struggled with something before they finally hit on the right solution. We're just seeing the right solution. There are 10 million YouTube channels, learn Python in 20 minutes, and that kind of thing, that are selling you really easy stuff. Documentation has all the easy examples, but generally not very many of the edge cases. So we do need to remind ourselves and our colleagues that what we're doing is difficult. It's not easy. It takes skill, it takes experience, and struggling is part of the process. If you're not struggling, you're solving boring problems.
Awesome. Thanks. That gentleman over there.
I know. I just have a comment to make. Myself and some of my colleagues that are here for the 2 days we represent a research institution. We're the South African's backbone for digital research infrastructure. I'll begin with talk later, but we have a Center for High Performance Computing, a national facility, and we've been, for the last 3 years, been running a coding school for South African teachers, and they come down to Cape Town and we teach them basic coding. And we got another 3-year contract that we just kind of renewed. But my comment is that I think that we are doing it wrong. I think that we've stratified software development to the fact that we are teaching coding, but coding is irrelevant in the next 5 to 10 years. Because we have, and we see it from what's happening in the industry, right? Wave 1 came about and we had the digital transformation that hit us. And we responded to that with all sorts of digital transformation interventions. We're now in wave 2, which has hit us about 3 years ago with AI-enabled research. We're standing on the cusp of wave 3, which is quantum-enabled research. We are teaching South African students how to code, but that's back in wave 1. And so the LLM story is really the story to help accelerate our students, so that they don't stay in wave 1, but they actually in fact can get to wave 2. If they are not helped, if they're not accelerated through LLMs, I think they'll be left behind, which they really are left behind. So my comment is that if you're going to teach and train our learners at primary school, high school, software development, I think we should not start 10 years ago where we were doing coding, how to train, how to code. Those days are gone. And I agree with my colleague that if you have the LLM today that can accelerate the skill set, why not use it? Because we've got to get them to quantum computing. We've got to get them to AI. We cannot sit there and teach them coding. So my comment is, I think that, and the other danger that I see is that we're teaching coding as if it's a trade school skill set. Our learners don't want to go to TV colleges. They want to go and study computer science. And so if we've kind of relegated software development to a trade, we're not going to get the buy-in that we need because those students want to do computer science, engineering. And so I think we kind of, the conversation for me has to shift drastically if you're going to educate the multiple students out there that kind of haven't got a skill to actually to participate in this new era.
Perfect. Thank you. I'm going to, okay, we have one more question. If I could just note, we'll take one more question and then I'm going to ask the panel to respond collectively, and that will pretty much take us to the end of the panel. So thank you, please.
Cool. Thank you. Also, I don't have a question, but just a note. A couple of people have made about I think especially after this last contribution, the biggest thing for me is thinking, mathematical thinking. Hidden behind coding is actually the mathematics of how something works and the problem solving. And I think Sheena and a couple of other commentators have made a point about understanding what things mean so that you can solve the problem, not just maybe just memorize the code. But also, I think other values that are important are respecting and welcoming different views, because problems get solved from different places. People solve problems differently. So it's also the idea of inclusion. So like for instance, I used to coach kids in mathematics, but the big thing there was growth mindsets and welcoming people, different ideas, different communities, and make sure that we can solve problems. I mean, technology, we talk about collaboration. You don't collaborate alone. You collaborate with teams, even at work. You can achieve productivity by working with others, not in silos. Thank you.
Thank you. Well, I'm going to basically
Can we let somebody else?
well, I'll take it.
The audience, I love.
Can I?
Let's respond to that one, and then I'll bring the microphone there for the last question.
Okay, cool. I'd like to respond to you because I think there's this is something that I've done a lot of research and thinking about, like excessive amounts. So the conclusions that I've drawn is that code literacy is going to remain important. Reading and writing code is easy. Software development is hard. And if you're not able to look at the output of an LLM and validate it in some way, you're going to shoot yourself in the foot. These things are going to get more powerful, yes. And they will abstract things, yes. We've been on this road where we've been abstracting things over time. Once upon a time, people coded with punch cards. Then eventually we got to things like C and C++, and then Python, which is a high-level language that abstracts away pointers. There's still pointers there under the hood. The question is what will LLMs abstract away? They're not going to abstract away things like the ability to do branching logic. Like, I want to do this under these circumstances, I'm going to do that 5 times under those circumstances. It's not going to abstract away problem decomposition. You're going to need these skills. Now, if you are generating code with LLMs, when you to solve basic problems, then you're not necessarily getting a chance to practice these skills in a way that your skills are getting validated by the machine. So those little coding katas and whatnot that people do on HackerRank, the goal is not to write the code. The goal is to learn how to break problems down, how to think through how data structures change over time. Because these skills are necessary on small scale, but they're also necessary on massive, massive scale. So those fundamentals let you practice those problem-solving skills in a way that you get feedback from the machine. And you get feedback from other people as well, because you can say exactly what you want. And people can say exactly what's wrong with your algorithm. Coding is like a laser beam. English is not like a laser beam. English is a blunt instrument. You get lawyers that argue about the meaning of a semicolon. English is never going to be as precise as code. It can be quite precise, but it's not going to be as precise. So that's the first thing. I still believe that the fundamentals matter. The second thing is looking at how code is changing due to LLMs, looking at how companies are using LLMs to generate code. It's important, it's always been important to have code that you trust, especially in production. If you introduce a bug, you can chase your users away. It's a terrible thing. So you need to have some trust in your code. If you're writing the code yourself by hand, then you trust it. Even if you follow sloppy things and you don't test it properly and you just kind of click test and you're like, yeah, it works, you trust it because you wrote it. And so there's a lot of sloppy coders out there. Now you've got this extra sloppy coder called an LLM that's writing that stuff for you. Trust is still necessary. How do you trust the code? Well, you could read it all yourself. That's one way. Or you can build guardrails. You could have really, really solid testing. You can have ways of finding out when things are going wrong. You can have good observability. So these kinds of validation practices, these engineering practices are actually becoming more important rather than less. How do you get good at that stuff? Fundamentals. So I fully, fully believe you need the fundamentals.
Just build on that. Sorry. Okay, thank you. Sorry. Logical reasoning is something that needs to be taught together with whatever and however we are going to teach coding in the future. We must remember what we ask LLM to do is what it spits out. If we can't logically put together a sequence of sentences how we want it, what's going to come out is going to be garbage in, garbage out. We all know this, right? I think I come from a generation where I still had to go to the library and read a book. Now people go to ChatGPT and ask them for the history of the Second World War. But the information can be wrong in either the library, depending on how you see it, or in ChatGPT. But your logical reasoning is going to let you know if that is right or wrong. So this is something we must not forget. That's the fundamentals you're talking about.
Yeah, and just to echo these sentiments about code literacy, just as an analogy, we all use calculators, but having a number sense is critical. When I add 2 plus 10 and I get 3,000, alarm bells should be ringing in my head. So, I get student solutions for an arcade game that they need to create. And it's the game works fine, the functionality's been achieved. It's completely unmaintainable code. And you could get LLMs to generate much better code, but they have no sense of what good code even looks like. So, I mean, that is critical. Having said that, I think also just in my assessments, like the primacy of code is diminished a little bit. It's still important, but yeah, looking at more at process, can you work together? Can you work in small increments? Can you collaborate? Looking at understanding the requirements, those things are gaining more importance now. But yeah, I definitely think code literacy is still a critical aspect.
Yeah. My comments have actually, you guys have.
Sorry, I was going to read one comment from our online audience, which will wrap up this LLM, but then we'll come to yourself and Benjamin, and that will pretty much.
Well, actually, I don't need to go because they've hit all the points I wanted to hit. Yeah, literally all of them.
Perfect, thanks, Kuzai. We had one comment from our online audience I'm just going to read out, which is also very pertinent to what we're saying that the impact of LLMs on learning is a serious concern, and sorry, I have to hold the phone closer because I'm not wearing my glasses, that in the near future, the only degrees and certifications that will not drop dramatically in value and trust will be ones from institutions that can afford to perform one-to-one in-person mentoring and an evaluation of a learner's skills, which is something we have somewhat touched on. Saying ubiquitous use of LLMs doesn't make it impossible to teach, but it makes it expensive to teach, because it undermines widely used techniques for evaluating understanding that are not great, but are more scalable. It's a valid yes, no? You have a reply then, and we'll take the Newman's.
Yeah, yes and no. Like LLMs can be really, really useful for teaching as well. And I've seen people teach themselves well with LLMs. So I teach advanced Python courses. That's my business. And a guy showed up who had decided to teach himself Python in 10 days by going through, I think it was a Stanford Python course. And I was like, guy, okay, you do your best. I'm not sure that this is a good idea, but it's cool. And then he showed up to an advanced Django course. I was like, I don't know, dude. But it was cool. And now he's doing great. He actually did super, super well. And that was partially because he had a strong why. And that was partially because he already had strong metacognitive skills. So he had good ways of saying okay, I'm going to use the LLM. And then when I hit a wall, I'm going to figure out should I dig into this or not? And then he'd make decisions like, this is something I really need to understand. LLM explain it to me. LLM, what went wrong here? Give me some resources. And then he'd go down the rabbit holes that he chose to go down. And sometimes he'd make good decisions and sometimes he'd make bad decisions. And if he made a bad decision, he'd come back and he'd learn the thing. And he did really well. It's super impressive what he managed to achieve. Many people can't do that. Many people don't have the same level of metacognitive skills just going into learning, which is a challenge. But I do think that it can be very, very helpful. I think for some things, it can replace a teacher in some ways, but not across the board. You can't automate all of it. There was something else that I wanted to add on to what I was saying earlier. I do think that the future belongs to people who can use these tools to code. So I'm not saying don't use LLMs to code, don't learn how to use them. I want to plug into something that David over there spoke about earlier, the loop of joy. And I think that's really, really relevant now. So when I was learning to code back in the day, I'd try to build a thing and then I'd build, hit a wall. And then I would need to go and figure out how to get out of that wall. And then that was my loop of joy. And then I'd get into another loop, build, suffer, success, yay. And I'd have these little loops. But now people have these big loops where they're start building, ask the LLM builds a freaking cathedral of broken glass. And now the learner's got 3 years worth of stuff to understand before they can even start fixing anything. They just hit that wall, but the wall is so far out of their reach that it's just this is impossible. And so it's important to keep that loop of joy as small as possible when coding with LLMs. So if you are a beginner programmer or if you're teaching beginners and encourage them to use LLMs, it's fine. It's totally fine. I think it's a good thing. But small increments. So cool, you want to build this cool cathedral? Freaking fantastic. Pick one feature, please. Make it work on your computer first. And once it works on your computer, then take on the next challenge, incremental challenges. And while they're using the LLM to do this, they will hit a wall. And then that's okay, because the wall isn't up here. The wall is something that they can almost look over, and then they can build on that. So yeah, like that gives them the skills of like that'll show them what the LLM can and cannot do. That'll show them how to use the tools effectively, but it'll also make it achievable to get the skills and iterate up as they make those loops as small as possible. Yeah.
Comment please, Stephen, and then otherwise we'll finish. Oh yeah, please go ahead, and then we'll finish the two questions.
I mean, this was just made to pick up on a different aspect on, that online comment you got, which I think LLMs are going to increase the digital divide even more, because you're going to have lower grade free, access to free lower grade LLMs which hallucinate more, and you're going to have to pay for high quality LLMs which can really help you, and like you said, help you debug and that. So yeah, I don't know. That's just a concern. I think that it's just going to make things worse in terms of the digital divide.
Thank you. I'm going to ask we've got two more questions from. My apologies, slight technical difficulties. We'll take two questions from my apologies, I've forgotten the name of my last question. And then, because it is pretty much tea time, I'm asked that we respond to that, and then we will wrap, if that works. So, Benjamin?
Thank you. For my first comment is we should have more panel sessions like this. I think this integration is really great in collaboration. My second one is a comment made earlier about how do senior engineers train juniors. I think just have systems in place, just like of HR, give a pack of notes or whatever to junior interns. Same for senior engineers, have systems in place, have YouTube videos you've done before to help, let interns, get, faster on track, onboarded. Last thing, which is I think quite important, has been mentioned, is a language barrier. Most of Africa, South Africa, English isn't the first language. So how do you train that, train technical skills to somebody whose first language isn't English? So just some comments, please.
Thank you. So I just want to set up the basis before I ask the question. So from my point of view, LLMs steal from the past by analyzing other code without reciprocating the prime generator of what was made. So if you take this in terms of education, someone like Geeks for Geeks Online takes knowledge and transfer that into a tutorial. Then people learn from that. Now LLMs go ahead, scrape that, take knowledge from an expert, induce inefficiencies, and then generate that for people at mass production, low cost. So what people tend to do, if you're making that tutorial, you've just been robbed of any reciprocation of value. So what people do is they just opt out. So how would people in the future gain value from teaching? And why would they even participate in a system where someone can just rob your value just like that? So just kind of, does anyone have an insight or at least the avenue to explore for people?
Sheena, anybody else? Or well, let's start with
Right. I'm convinced we are social beings. People want to interact with each other. I will be very surprised if one day we do not interact with each other and talk to each other. And learning is one way to do that. But I agree with you that LLMs scrape and take other people's work, and that ethical use of it should be encouraged. And we're still figuring out what this ethical use is. But I agree with you. Thank you.
Actually, just sort of wanting to return this to pedagogy. I read a description, it's not somebody I know personally, but a teacher of like school children who has recognized that all the children are, cheating and making all the assignments, not necessarily programming, but, the history paper or the whatever, it's being written by the machine. And to say, okay, that's fine, do that, turn in that paper, and now the real assignment is find out everything that's wrong in what the LLM did and go do that research of figuring out where it went wrong. I mean, that could be a history paper, but I think that very equally can be a programming assignment. And that's maybe a productive way to learn how to interact with machines and to make people actually learn and not just produce the mechanical result.
Yeah, maybe just in a coding context. I mean, I tell my students, like, don't use an LLM to generate the solution. You write that yourself, but then get it to review your solution, so you can get that feedback, and then you can get useful feedback. So.
Yeah. So your question was about like why should people teach code? Yeah. Yeah. So there's lots of reasons. So so for somebody who is like a coder, I can give you a good answer for a coder to teach code. So it is like the stuff I was talking about earlier about sharpening your skills. You really, really do plug in the gaps. That's one big thing. Like you level up massively, and your communication skills level up massively. Somebody I know named Kim recently said the primary output. I don't know where you got it from originally, but. Yeah, so I'm stealing it from Kim. It's not his. It's open source. Yeah, the primary output of a senior engineer is another senior engineer. In order to get that right, you need to be really good at explaining yourself, and you practice that through teaching. So if you start off teaching foundational stuff, then you can teach more advanced stuff. Then you can teach people of different backgrounds the stuff, and you can explain yourself better to non-technical stakeholders. Like that is really, really valuable. So for like techies, teaching is good for your own personal growth, even if it's not always something that you can like you can put it on your CV and people will be like, oh, and this is a nice person. But there are real skills that you polish up by doing that. And then the other thing about teaching that is really powerful, like we just did a Django Girls, we just did a Humble Data the other day, and that was fantastic. Dawn shared her story during the keynote, and her story was like she went to one of these workshops. The workshop's short. Like Django Girls is a day or two. Like it's a tiny little thing. How much can you really do with that? Not a lot. But the connections that came out of that changed lives, like in significant ways. It's like you plant a lot of seeds and some of them just like grow and you're just like, wow, you got really tall. And that's like, it's a fantastic thing to be a part of, because you can see like the effect that you had on people and you can see the effect that they have on more people. So there is also like a do-gooder aspect to teaching. Then I think for like people who teach professionally, like I think it's a beautiful thing. It's rewarding. It's not just about like people can copy my stuff. It is about the human interaction, but it's again about setting people up for success. Like I spent quite a lot of time working in non-profit stuff, teaching people like from zero to professional, like getting people into their first career. And what was cool was like a lot of the time these people could teach themselves, and I just needed to be a bit of a cheerleader. A couple of sentences could change a person's trajectory massively. Like there was one guy who had so much potential and he went AWOL, like he just disappeared and nobody could get hold of him, and like he wouldn't pick up his phone, and I sent him a WhatsApp message. And this was a thing that I did, like if a student was like having a bad time, I just send them a WhatsApp, and then I'd be like, maybe they'll read it, I can't get hold of them another way. This guy came back, he top of his class, we ended up hiring him. He became the best, like amongst our junior devs on the team, he became the best one. And I forgot about that message. And years later, when I left that organization, he reminded me, he was like, Sheena, that message changed my life. It was a sentence, one sentence. So you get to do that. So yeah, teaching is totally worth it.
Yeah, great. There's a lot of work that needs to be done with languages. I know you spoke a little bit about that yesterday in your talk. Glossary is doing a lot of work. I know there's a lot of translations. Fundamentally speaking, learning in your mother tongue is the best way. I don't have the final answer for you on how we can do it better, but I think doing something is better than doing nothing. And at the moment, if the community comes together and we can build on all these foundational kind of projects, that's better. I think resources, tools, making it freely available. I don't need to pay for a dictionary where I can find out what standard deviation is in Afrikaans or in isiZulu. I think that's the most important part.
Otherwise, I think that's us done. Thank you very much to our panel. I think that has been fantastic. Yeah. I will just stand so you can see what I'm doing. Thank you to Sheena, to Dr. David, to Angelique, and to Dr. Stephen. That was absolutely brilliant. We don't do enough of these panels. Every time we do it, I've seen comments online from people saying absolutely brilliant. I suspect many of us agree. Benjamin, you said as much. Panels are really worth doing. Thank you very much for coming, everyone.